Tuesday because we are now talking about the nervous system, and we looked at parts of the neuron, kind of did a brief overview of the divisions of the nervous system. So we left off at the point where we talked about axonal transport, because one of the things that happens when we have a neuron, and I kind of want to stress this, okay? You'll always see that we have those dendrites, the big cell body, axon, then those little terminal ends. And the product that is made is going to be that neurotransmitter. So we kind of left off at the point where we found out that this neurotransmitter has to travel to these terminal ends so that when there is an action potential, that neurotransmitter can be released into the area of the synapse. Does everybody remember that? Now, this terminal end, what can it be connected to? What could it be making a connection with? It could be making a connection with a muscle,
a gland, or another neuron,
a gland, or another neuron. Okay, everybody following me so far? So that was pretty much the point that we left off. And we had looked at some of the types of neurons, and we determined that this type right here is going to be the most common. That's what's going to come to mind when we hear the term neuron, nerve cell. That is not always the case. However, the activities of the nerve cell are going to pretty much be across the board. One of the things that was mentioned on Tuesday is that we have our central nervous system. The central nervous system, what makes that up? What parts of our body make up the central nervous system? Our brain and our spinal cord. Then I mentioned that we have our peripheral nervous system. What is that? Now, when we say everything else, is there something a little more specific that we can add to that?
the nerves that branch out from the spine.
They're going to be the nerves that branch out of the spinal, out of the vertebra. Okay, that even though we're saying the spinal cord, I kind of like to have that visual of those nerves exiting through the vertebra, if that makes sense. They're called our spinal nerves. All right? They exit from the spinal cord. All right? Is everybody with me? Now, we mentioned that these cells, they are not going to worry about reproducing. So one of the things about it, neurons are very busy. Neurons have to make sure that they get nutrients, that they get rid of their waste. The way that the cells are going to do that, they're going to have support cells. The support cells in the nervous system. Note, I did not signify one or the other. I simply said the nervous system. The support cells are called glial cells. So these are neuroglia. They are going to help support and protect the neurons. Because our neurons are going to be the cells that will receive a stimulus and transmit the action potential with the parts that they're going to contain. Your dendrites, the nerve cell body, axon, terminal end. Because I have my central nervous system, my CNS, and my peripheral nervous system, I'm going to find glia in both. There are some differences, and they're pretty major. When we look at the glial cells of my central nervous system, note that's what I'm trying to let you know on this slide right here. My central, what part? My brain and my spinal cord. I'm going to have a cell called microglia. Just like the name implies, small, okay? This is a specialized macrophage. Now, I just said a small cell, but now it's telling me macrophage. This is the cell that can eat bad stuff. Okay? Because phage means to eat. Macro meaning it's a big cell. So this is going to be a cell that can respond to inflammation, dead tissue, necrotic means dead, microorganisms, and foreign substances. Do I want any of that in my central nervous system? Oh no. Because if it gets in there, bad things are going to happen. Alright? So, they are really good at helping keep it clean up. Alright, for example, a person who dies of a traumatic, blunt force injury, whatever you want to call it, to the brain, okay? Because those cells recognize that tissue got damaged, they're going to immediately go to that area of the tissue that got damaged. Now, most likely the person died, okay? And that's one of the things that the coroners can use to help determine cause of death. And oligodendrocytes. I love this cell. Look at what it gets to do. When you are looking at the brain and the spinal cord, we are going to see that we have gray and white matter. Do you happen to know the difference between them? Do you know, have you ever heard of the fact that we got the gray and the white? Okay. So, this is kind of old, all right? And this is representing the gray and the white, but this kind of turns brown, okay? Because it's a really old model. But we're going to go with this, okay? And this area right here, gray. The rest of it, white. Does that make sense? Okay. So, my gray being represented here, and the white to the outside. Okay? So this little area right here, okay, like I said, the colors have changed. Okay? This is representing my gray area and the white. Okay? So, if I'm looking at this, okay, where it's letting me know gray matter, white matter, because this is a cross-section of my spinal cord going through a vertebra. Y'all kind of see that? Okay, so gray matter, the reason it's termed gray, when you get to cut the human open, okay, and you get to see that cross-section fresh, it has a gray appearance. So therefore, being termed the gray matter, okay? What this is telling me, now for a long time, all right, what it said is that those axons are not myelinated. They don't have myelin. That is not the case. What it says, or what's happening is, the myelin is different. Okay? Now, when you look at the central nervous system, when you look at the brain and the spinal cord, myelin, do you happen to know what it is? It's a fatty substance, okay? And it is a cushion around the axon. In my brain and my spinal cord, the way that we cushion those axons, we have an oligodendrocyte, this particular cell right here, and what it will do is it will branch off and create a wrapping all the way around an axon. And that one cell, think of my body right here as being the oligodendrocyte, and these are my extensions, okay? That one cell can have many extensions, all right, all going to wrap around an axon within the brain or the spinal cord. Does that make sense? So that one cell can have all these different extensions branching out to wrap. Okay? You're thinking about those canaliculus that are making a connection, okay? And we're getting branching here that'll make connections to an axon and wrap around it and support it. And because the wrapping is not as specialized as what you'll see in the peripheral, okay, it makes it look like they're not all covered. And technically they're not, okay? But they're protected in some way. Just a lot of difference in the peripheral. When we look at now we're still in the central nervous system, which means my brain and my spinal cord. All right, so for the most part, when you think of brain, this is what you think about, right? This part right here, the big noodles. Okay? This area. This, pretty much run the show. Okay? This area that we associate with being the brain, it pales in comparison to the other portion. But one of the things that's going to happen when you look at the brain, located throughout this tissue, pretty much right here through this like little midsection right here.